Chairman. Good afternoon, everyone. I have the chance today in 15 minutes to provide you the presentation on fiber solution and the lithium-ion-based modulator and the pulse generator for fiber lasers. So the title has been changed a little bit, but the main material I'm keeping the same. My name is Zhang Shuo, iXblue Photonics manager based in China. All of iXblue products are made in France. We have 8 production sites, and each site makes the specific product like gyroscope, sonar, and the motion system. Today, I will talk about 2 sites belong to iXblue Photonics division. The one based in LiNbO in the west of France, where the optical fiber are made. Besançon in the east of the country, where the lithium-ion modulator and the related components are manufactured. I will start to introduce iXblue Photonics division, our main product. In the second chapter, I will present our electro-optical modulator and the fiber for different high-power laser application, including the beaming combining and the high-energy laser as well. I will finish by the fiber laser application using our modulator and the fibers. An overview of our fiber family. We are offering from single to triple clad, passive and active fiber with neodymium, ytterbium, erbium, thulium and holmium doped, core diameter up to 30 micron and the wavelength up to 2 micron. We are also making the IPG for high power laser cavity up to 3 kilowatt. Our key feature is high temperature coating, radiation resistant, and space qualified. For the modulators, we are offering a wide wavelength range from 760 nanometer and 2 micron. Thanks to our special technology, we are offering in the world the best optical power handling up to 300 milliwatt with excellent stability over time, highest polarization external ratio up to 40 dB, and the highest static external ratio modulator down to 40 dB. For the modulator facility, we are not only making the components, but also the turnkey system which integrate the laser, modulator, driver, bias controller, and the AWG as an optical modulation unit for either the sub-nanosecond pulse generation or spectral burning unit. I will come back to this point later. So in the main topics of this presentation, I will introduce our electro-optical modulator and the fibers for coherent and the spectral beam combining and the high energy laser. So the laser based on the coherent beam combining is able to produce the power up to 100 kilowatt. So this afternoon I heard many of you are talking about phase control. So I suppose that you are using the phase modulator. I hope you are using iXblue, or previous name is Photonics phase modulators. So in this application, the phase modulator is needed for each beam to equalize the optic patch between each beam and maximize the energy and power by constructive interference. Usually, the working frequency range is from kilo to megahertz. So what's the specification requirement for the phase modulators? It has to be low insertion loss and high power optical power handling. The frequency range must be from DC. That's because an important point is a pure phase modulation is required without any amplitude perturbation. And we call low RAM here. So RAM is residual amplitude modulation. It's the ratio between the power perturbation and the average power transmitted by the phase modulators. So this RAM is expected to be close to 0 for a perfect phase modulator. This amplitude perturbation is due to different regions. For example, the input and output offset of the waveguide create an effect of weak optical cavity, or the interference between the main waveguide and the parasitic reflective waveguide. So, how to mitigate this amplitude perturbation, this low run? Let's go to the next page. So the modulator using incoherent beam convening is able to handle optical power up to 300 milliwatt with good stability over 1,000 hours. It has low Vpi down to 1.5 watt at 50 megahertz, and the Vpi of phase modulator is proportional to the frequency. That means once the frequency is increased, and the Vpi increases as well. So to mitigate this rump effect, our dedicated modulator NIR MPX LN0.1 is a DC coupled device. It allows to apply the DC bias voltage on the phase modulators without damage. By applying this DC bias signal on the phase modulator, we are able to reduce the run from typical 30 dB to 40 dB thanks to pattern technology. So similar to the coherent beam convening, only the phase modulator is using for the spectral beam convening. Thanks to the presentation by the Frank on the previous speech, I will not add more experimental results here. So typically, 4 types of RF signal is using for this application. Currently, many are using the white noise source or the TRBS. So we have identified the need of wide electro-optical bandwidth for this application. We propose different kind of phase modulator from 3 GHz, 100 MHz, and to 18 GHz. This phase modulator integrates a specific RF load which allows to handle the RF input power up to 33 dBm, equivalent to 3 watt. So thanks to our good uniformity and the repeatability of manufacturing process, we are able to select much better performance than the standard one. For example, the low insertion loss phase modulator could be down to 2 dB. So previously, I introduced some few examples of beam convening using the phase modulators. Now let's go to the high energy industrial laser, which enable to generate laser pulse in the range of few 10 nanoseconds and the pulse energy up to 100 joule. This laser is using for laser pinning, plasma, and shock pieces, which need a perfect square wave with top part, H shape, and high energy. This high energy could be achieved by cascading the fiber and solid state amplifier. But because the distortion coming from this amplifier, and in order to generate a perfect square wave, a pre-distortion, sub-nanosecond laser pulse could be generated by amplitude modulators. So this amplitude modulator, it has to be a high eccentricity ratio in the range 25 to 35 dB. It has to be low insertion loss and high power handling in order to relax the gain effort from the amplifier. From this laser setup, we have identified a cedar source with a fiber laser, electro-optical modulator, and a fiber amplifier. So this cedar source will be called model box fondant system during this presentation. And this fondant system, it allows the temporal shaping and the pulse energy in the range nanojoule and high optical pulse contrast stability over time. And this setup could be also using for the high energy scientific high energy density laser, which enable to generate the laser pulse energy up to kilojoule, even megajoule for the superstructure laser project, like beta watt in China, megajoule in Europe, and EVE in US. So we have identified the seed laser plus the additional phase modulator using in this setup. Compared to previous requirement on the phase modulator, on the amplitude modulator, now we add the need of low V-pi phase modulator in order to generate a large number of side bond and also the high polarization external ratio by the PZ fiber. For example, the MegaJoule project in Europe was already using the PZ fiber instead of the PM fiber. And the NIF in US is going to this change. And from system point of view, we also add the need of spectral broadening unit and the high polarization external ratio. So a quick overview of our module condense system. It allows to generate the pulse width from 100 picosecond to 100 nanosecond, repeat rate from single shot to 100 kilohertz, with low time jitter down to 7 picosecond. So the modbox not only offers the good performance, but also the good stability over time. We can guarantee the external ratio and the optical power stability is the 1% RMS. So for such high power and high energy laser, the special fiber is used for either the high polarization external ratio or monitor the power. We developed the special medium mode gradient index fiber for MegaJoule project to transport the power to the detector without dispersion and distortion. And this fiber is also radiation resistant. So in the last chapter of this presentation, I will go quickly some few fiber laser application using our modulators and the fibers. So first, the femtosecond laser based on the neodymium fiber. A recent research results show that we can develop a deep UV laser at 226 nanometer using a double-clad PM neodymium fiber. We also offer a large selection for the erbium and the ytterbium fiber for the terahertz generation, supercontinuum, or the life science applications. And the 2-micron fiber is strongly attractive customer attention in the past few years for defense or the medical application. We are offering from a single, double to triple clad, thulium, holmium, and or dual doped fiber with latest result this year thanks to many government projects. And for LiDAR market, we develop special erbium ytterbium fiber for Google autonomous driving project. Our high acceleration modulator allow to generate very clean sub-nanosecond laser pulse. For the long-range LiDAR measurement, we develop a large mode area erbium ytterbium fiber to reach the worldwide record on wind speed measurement over 16 kilometers. We also develop a special 1 gigaphase modulator for this application. iXblue is the leader for the erbium and the ytterbium market. We are offering the high temperature coating at 120 degrees C instead of standard 185 degrees C. In order to handle the high power by the small size fiber, we have the solution based on the all glass design to avoid the heating effect on the coating, and more than 30 reference dedicated for each applications. So as iXblue is the unique fiber and modulator company in Europe, we have developed a lot of space projects with ESA, European Space Agency. And for example, the erbium ytterbium standard telecom fiber is attenuated very fast with the radiation. So the dot line on the left, that means the standard fiber cannot be used in space, let's say few years. And with special dotted fibers, This fiber has been already using for a few 10 years by more than 30 satellites flying. So same for the modulators with ESA, European Space Agency. iXblue create the standard of space qualified modulator process. All of our space modulator can pass the testing, the reliability testing used in space. For example, the radiation, vibration, shock, vacuum temperature, or the more than 20 testing depends on the customer requirement. And our space qualified modulator 815, 1 micron, and 1515 has been already selected by different space mission in China, US, and Europe. So thank you for your attention. I hope my presentation gave you a good impression for our performance and good reliability. And please feel free to contact us if you have any question. Thank you.
Any question?